The next part. Hello, everyone. Good day. Welcome to attend Hikvision HCSA CCTV training program. Today we will introduce Hikvision optics basics for you. These are three main objectives for this course. Firstly, understand basic components and concepts of lens. Secondly, become familiar with the key parameters of lens. Thirdly, according to this knowledge, we are able to select suitable lens for different requirement. In order to achieve these learning objectives, this course includes these three parts. The first part is overview of lens, in which we will talk about what is lens, what compose of lens, and how lenses are classified. The second part is key parameters for lens, such as FOV, iris and f-number. The third part is the method we usually use for lens selection, including focal length estimation, lens type and naming rule. We will start with overview of lens, including definition and classification. Lens is not a rare thing in our daily life. We know lens is used to take photos or take videos. Lens collects optical signal and form an image on the sensor, so we can get photos and videos. The principle is very similar as our eyes. Therefore, you can think lens as the camera's eye. As shown in the sectional photo of lens, it has one or more groups of optical glasses. The second picture indicate the working principle of lens. It collects and focuses light on sensor. Sensor can be CCD, CMOS sensor. Then, image generating process happens, and form image on the sensor. Different combination of lens result in different focal length. We will introduce more about focal length in the next slide. In this drawing, we have sensor, camera lens and targeting view, which we want to take photo. The focal length is the distance between the camera lens and sensor. The angle of the lens is the angle that lens can view. These two parameters are very important for a lens. I will tell you why in this course. Lenses can be categorized according to various factors. According to the imaging size, or FOV, field of view, mount method, whether focal length can be varied, iris type, resolution level, and whether equipped with IR light. All these factors will be introduced in the next part. Now, let us think about two questions to make a review about this part. What is lens? From the perspective of its function, lens is to collect optical signal and form an image on the sensor. From the perspective of its composition, lens is consisted of one or more groups of optical glasses. The second question is what is focal length? Focal length is an essential factor for lens performance. It is the distance between sensor and lens. Okay, we move on to the second part, and talk about key parameters of lens, including field of view and f-number. The first parameter is FOV. FOV means field of view. It is the extent of the observable world that is seen. It is measured at 3 dimensions, horizontally, vertically and diagonally. Obviously, the two pictures below are taken in the same place, but their FOV is different. So which one you think has larger FOV? The first picture, right? There are two factors influencing FOV of pictures. They are sensor size and focal length. In this drawing, H and V is the horizontal and vertical FOV. H and V is image width and height, or you can say they are the sensor size. D is the monitoring distance. F is the focal length. We keep the monitoring distance constant. When the sensor size is fixed, longer focal length will make smaller FOV. When the focal length is fixed, larger sensor size will make larger FOV. When we take photo or video, sometimes we want large FOV, so we can contain more scene in our image. Sometimes we want small FOV, so we can view our target object clearly. What we usually call it zoom in. We have these four types of view: normal view, telephoto view and wide-angle view and panoramic view. You see the telephoto view has the longest focal length, because it has smaller FOV. The panoramic view has the shortest focal length, because it has largest FOV. Lens can control the amount of light reaching the image sensor. How lens controls light passing through it? We use iris. Here I will introduce a very important parameter to you. F-number. F-number is used to measure the amount of light through the lens. F-number equals focal length over iris diameter, because both focal length and iris diameter can affect the light reaching sensor. Focal length is the distance between the sensor and lens. When sensor is nearer to lens, it can receive more light. Iris is between lens and sensor. Larger iris diameter can allow more light to reach sensor. This picture shows us the label on lens. There is focal length range, imaging size, mount method and maximum f number. It can be 1, 1.4, 2, 2.8, 4. Now let us think about a question. Whether the large f number or small f number indicates more light reaching sensor. The answer is smaller f number means more light. The relationship between f number and iris size with a fixed focal length is that lower iris size leading to larger f number and lower amount of light. For the second part, we also have 2 questions for you to review this part. Firstly, for FOV, field of view, which factors affect it? Sensor size and focal length. When the sensor size is fixed, longer focal length will make small FOV. When the focal length is fixed, larger sensor size will make large FOV. The second question is about f number. Choose which lens in these 2 pictures can capture a brighter image. If only decide with iris diameter. You may think the right one will capture a brighter image, because it has larger iris diameter. However, you forget the influence by focal length. We can get correct answer according to f number. The left one has lower f number, so it can capture brighter image. Then, we will go to the part 3 lens selection, including focal length estimation, lens type and naming rule. When we talk about the classification of lens, we found lens can be classified according to iris type. Now we will learn about what iris types we have. Manual iris lens is the easiest type of lens. It is made of several plates of metal. There is an OC ring on the outer diameter of lens, which is used to control the iris size. It is suitable to indoor scenarios with constant lighting, such as elevator, building corridor or room without windows. At the installation of lens, we can adjust the iris diameter until we get a satisfying image. Then we do not need to adjust it anymore. However, in addition to iris diameter, we also can use shutter speed to change brightness of our image. Therefore, with electronic shutter to compensate, it can also be used for changing lighting scenarios. The second type is auto iris. It is suitable to scenarios with changing lighting, such as outdoor environment. There are 2 major subtypes. Video drive iris has amplifier inside iris. Amplifier is used to control the iris diameter through driving iris motor accoding to the feedback video signal. DC drive iris is controlled by camera's DC voltage, therefore the amplifier is installed inside camera, but not in iris. The third type is P-iris. It can achieve better depth of field, which will be introduced later, and more precise adjustment. The lens motor is controlled by camera algorithm, so the iris is adjusted precisely and keep in optimal position. Optimal image quality is achieved. Lens has various different mounting types. Zoom camera lens is used in 4 series Hikvision camera and PTZ dome camera. 514 mount lens is used in bullet camera, dome camera. M12 mount lens only has fixed focal length, used in some small cameras. CCTV mount lens is used in box camera and capture camera. We will further compare the difference between CCTV mount lens. The diameter of screw thread is 1 inch. The difference between carbon monosulfide mount and C-mount is the flange focal distance. For carbon monosulfide mount, it is 12.5 mm. For C-mount, it is 17.526 mm. If we want to use C-mount lens on carbon monosulfide mount camera, we need a CCS adapter ring with depth of 5 mm, as shown in this picture. In real application, if we install carbon monosulfide mount lens on C-mount camera, we cannot get clear image, because imaging cannot locating at the sensor, and if we install C-mount lens on CS mount camera, lens would touch protection glass for sensor, and results in camera damage. Therefore, we need to be very careful. When we talked about FOV and F number in last part, we should realize the importance of focal length for image quality. Therefore, focal length is a crucial factor for lens selection. We did a test to observe what image we can get with different monitoring distance and focal length. Monitoring distance means the distance between the camera and object. We cannot say which image is better than others, because it depends on what image we want. We can estimate suitable focal length according to the image we want and monitoring distance, but this estimation is only useful for the lens with more than 4 mm focal length. For a person is 10 meters away from camera, we observe that, to see face clearly, we should use 20 mm lens. To see human feature, we should use 10 mm lens. To see human actions, we need 5 mm lens. Therefore, we conclude these results, as shown in this table. How to use this table? Firstly, get the monitoring distance. Then calculate focal length with this table. For example, if you want a photo showing human profile or human body, and your camera is 20 meters away from the person, you will need 20 mm focal length. Finally, you can choose sensor size you want. If there is no such lens with exact the same focal length, usually we can choose the smaller focal length to have a larger field of view. Normal lens can be divided into fixed focal lens and varifocal lens. Fixed focal lens is suitable for fixed monitoring indoors. Because the focal length is fixed, usually we need electronic shutter to adjust the lighting level. Varifocal lens is suitable for the case that need to change field of view or field of view is very large. With varifocal lens, we can change focal length to some extent without changing the camera position. For fixed focal lens, we should choose suitable focal length, otherwise, we cannot change it. Short focal length means focal length smaller than imaging size. We also can call it as wide-angle lens, mainly used for environment with weak lighting, and scenarios requiring high field of view. Middle focal length means focal length is similar to imaging size. It is standard lens, focal length depends on the sensor size. Long focal length, which means focal length larger than imaging size. We can call it telescope lens. It is suitable for scenarios need narrow coverage or field of view, and if you want to view the objects in very long distance away. For varifocal lens, the focal length can be adjusted manually or electrically. Manual varifocal lens use adjustment ring. It is suitable for non-familiar scenarios with strict requirement which cannot be fulfilled by fixed focal lens. Therefore, it is widely used in many projects with fixed monitoring target. Electric varifocal lens has 2 micromotors, one for focal length, and one for lens focus. Therefore, we can use electric varifocal lens in some scenarios need frequent change of monitoring object or the field of view. Megapixel lens is used in megapixel camera. Comparing between these two pictures, you will see megapixel lens can get much clear and sharp image after zoom in, especially in for edges. In order to take bright image in some very dark environment, we need cameras with IR light. For these cameras, we must use IR corrected lens. The wavelength of visible light and IR light is different, resulting in different refraction rate. So their focal plane will be different. Then we will get a blurred image. IR corrected lens can solve this problem. Sphere lens results in spherical aberration, distortion, because light cannot focus on one spot. Aspheric lens can correct all these problems. Aspheric glass lens need high manufacture technology, so it has high cost. We also have some special lens, such as fisheye lens and pinhole camera. Finally, let us learn about the naming rule for Hikvision lens. It will be helpful for you to select suitable lens. The first digit means the imaging size. The second digit indicates whether the lens has fixed focal length or varifocal length. These number means the range of focal length. This digit before dash indicates how iris is adjusted. The digit after dash shows us whether the lens is megapixel lens or IR corrected lens. Finally, let's make a conclusion of this course. We have 3 main parts in this training. Start with overview of optical lens. We talk about what is lens, what it look like, how it works in camera, and how lenses are classified into different categories. Then, we talk about 2 key parameters of optical lens, FOV, field of view, and F number, used to indicate the light amount passing through lens. In the last part, we talk about how to select different types of lens for various application scenarios, such as iris types, mounting types, focal length, and so on. Okay, these are all the contents for this training. Hope you have got a better understanding about Hikvision lens. Thank you for supporting Hikvision. See you in next course.